T2 demos. T2 demos. T2 demos. This is the first test to try to do time-lapse with the X-T4. There's the parameters. We're going 300 times. Speed up, these are JPEG frames. There's lots of problems with this, but it's fairly encouraging. I'm worried, since this is just one power zone, I'm worried about when we get to like 9 power zones, whether there's going to be enough res. But we'll see in the second demo where I do some camera projector automation, I'm calling it, that it looks pretty good. We can push from here, we can push all the way into a single tile after the fact and still like read the text, for example, which was not really true with the previous solutions. I don't know if that will still be true with 9 power zones, but we'll see. So this was a big update of almost everything, because I hadn't had this grid fired up for quite some time. I'd been working on the single ring, and then obviously just doing a Hugene run, which I wanted to run until it settled one way or the other all by itself, but I didn't really understand how the Fuji X-T4 works, and its battery died. So that's where this simulation ends. All right, so here we are pushed into a single video, also with a little bit of color grading, since the background of the CDM menus really should be brown, and the LCDs we're using are really so low quality. So I've just tried to get this to approximate, to sort of emphasize rendering what passes for true colors on the LCDs, and let the the T2 tile cases and the surrounding environment and stuff go hang. But I'm also, and this is using the Kdenlive transform effect with keyframes that are set to smooth, which is cubic splines, I think. And I'm starting to get them working. You can see that this is actually fair, and it doesn't have a lot of changing in directions that don't make a certain amount of sense given the action on the screen. So this is it. This is the first test. I've now got an order for one of these dummy battery things that connects to a charger so that it's not relying on USB power. So hopefully we'll be able to do much longer. Lots more stuff to do. Just figured I'd put the first test up. That's it. Hey folks, welcome to Artificial Life Creation T+3 and swimming. It's about the fish. So the goals for this time was number one, to submit a paper to the A-Life 23 conference. I did that, talk about it a little bit. Number two, to get coordinated movement of multiple different cells in a multicellular creature. That's what we just sort of saw. Also to get Companion to Caring, my dad's book that we just published, in stores, meaning on the web. And we did that. We'll show you. And of course, always have big fun. It was a mixed bag. I'm struggling with this multicellularity stuff, but it was fun when stuff worked, and there was good fun in various spots. Okay, so the schedule. We were supposed to have coordinated movement this time. We sort of semi have coordinated movement. The fins kind of bounce along behind, but they're doing better than they were last month, and that's all I can really hope for myself. And in addition, coming up next month in May is supposed to be junctions and intercellular signaling, but really we have to have something like that in order to do coordinated movement. So I've already kind of reached ahead to that, and I'll talk about that a little bit today. All right, fish gotta swim. There's a person, Samter, who's been catching up on the videos for the last several months, asking lots of good questions. And in a way, sometimes the questions are a little bit challenging, and I don't actually get enough time to go back and give good answers to all of them. But I do sometimes. I try to. And I have to say that figuring out how to respond to a pointed question, like that, polite and everything, but, saying, it seems like this was kind of, pointless, or system becoming rather bespoke, so getting very specific. And my reply to this is that we have this idea of like major transitions in evolution. When you're doing engineering bottom up, that you're gonna have to build the pieces, and then you're gonna build a thing out of the pieces. But you're not done there, because then you're gonna step back and make machines that are bigger and slower, and use the thing that you made out of the pieces as a piece in the next level, and so on. And the major transitions in evolution, from chemistry to biology to multicellularity to societies and interplanetary hoo-ha, are all examples of that we keep stepping back, make machines that are bigger and slower, and use what used to be the pride of place of a single thing as now just a mere component of a larger system. And structure at all scales ended up being sort of the punchline of the artificial life paper I submitted. So this is part of what's going on. Multicellularity is making that next step. We've been working at atoms and molecules up to a single cell, and that was pretty good challenge all by itself. But now we're trying to go to the next level, and it's hard. Why is it bigger and slower? And part of it is the design, that we're now up at this multicellular level. The language itself doesn't really know anything about the language is still about event windows, atoms, sites, and so forth. So I'm writing a lot of code. I'm not feeling good about the code I'm writing. I'm cutting and pasting a lot. The design that I'm going for is getting out ahead of the tools. And, on the one hand, you say that's bad. But on the other hand, this is a design foray that we're trying to get out into the wilderness and spring the bear traps to find the deadfalls, so that we could help figure out what kind of tools we would want to help us the next time around, rather than think we can sit in our abstract armchair and just derive what the tools ought to be without actually getting out in the field. So one of my worries is, multicellular menagerie. When I started this 6-month run, I was thinking, oh, hey, I'll just knock out a new multicellular creature every month. And so the first thing that I made was, add 2 little half-size cells next to a full-size cell and call them fins. That was so trivial, and I'm still on it. The fish swimming may be the only thing in the menagerie. Maybe there's just going to be a whole bunch of little fish swimming along. We shall see. So, but along the way to getting there, there's been a lot of progress. And part of it is, in the single cell system, the edge of the cell, the membrane at the edge of the cell, had basically one job, which is to say, is there anything out there Is it a wall? Is it the edge of the universe? Is it another cell? Anything. And I just want to stay away from it because I want to, keep from getting overrun, keep getting into it and so forth. But in multicellularity, it's not that simple because we have to do identification friend or foe to some degree, because if it's another cell out there that's part of us, that is part of our coordinated collective, then we're more willing to stay close to it than it is if it's some kind of random. So there's this concept now called corner distances, where the M base atoms, those are the innermost membranes that are right next to the edge of the hard cell 3 grid itself, they talk to each other and they localize themselves with respect to each side. So the corner distance of 0 is how many pockets there are. Excuse me for a second here. I've got terrible allergies. You can probably hear it in my nose. How many pockets clockwise and anti-clockwise this particular M base is, and they all figure it out. So this one up here is 3 pockets clockwise and 1 pocket counterclockwise. This one is 0 clockwise and 4 counterclockwise, and so forth. So with corner distances, you get 2 pieces of information. You can add up the corner distances and figure out how long the side is, which tells you how big the cell is, in a sense. Or you can look at the specific numbers and tell where you are, how far clockwise you are along whatever side you're on. And the next level out, the cyan M sensor atoms, they pick up the corner distances now from the M bases, and the intercellular goo, the brown stuff, which reaches out quite far, picks up the information from the M sensors or the M bases, whatever they can happen to see, and carries it out further. And finally, the neighboring cells, in this case, there's a new special kind of hard cell grid atom called an edge Hg that has additional behavior just because it's on the outer edge of the diamond. It now has inbound corner distances. So what we saw out over here, where is it? There it is, an M base saying I'm 1 clockwise, 4 counterclockwise. That went out through the M sensors into the intercellular goo and eventually reached this edge. So this guy can now say my neighbor, number 1 is size 5, and number 2, we are approximately at 1 clockwise, 4 counterclockwise on that cell. And that's how the fish fins are now trying to localize themselves by looking at that corner distance information that's coming in from the neighboring cell, and vice versa. The position of the fin is being transmitted by the same mechanism to the fish body. And now the fish fins and the fish body each have a special controller atom that rides up right and sits right next to the root and looks at all this information come in and overrides what the root would normally do as far as moving around and trying to get away from everything. All that behavior is still there, but we're overriding it to say, no, that's a friend, let's stay closer to it than you want to, and so forth. And if something goes wrong, if the controller dies, then free will, the lower level, that's my new definition of what free will means. Free will in an API means you have nothing to say and you let the implementation do whatever it wants to do, and that's free will at the level of that API. So the fins in the body are now mutually servoing each other. The fins are trying to stay in the middle of their assigned size. The body is trying not to get too far out ahead. And, it kind of works. And, it worked well enough that I put it on the grid. And, it's just starting, so there's just a little bit of this. But it's doing all right. The MFMS simulator is carrying over to the T2 matrix. Yeah, I've officially renamed the thing that we're looking for, the hardware. I'm calling it the matrix now, not to put too fine a point on it. So, the controller, the fishbod controller, see, look at that. It's going down, changed its mind, it's going up, it's cruising along. And the fact that it was going a little bit left and right there, that was the servoing for the body trying to stay in between the two fish and help it out, the two fins, and help it out, and so forth. So progress it is. Big science. I wrote an 8-page paper for the Artificial Life 2023, submitted it with 2 whole minutes to spare before the absolute drop deadline, went and got some sleep, came back to this thing saying you have 24 hours to meet this requirement for that you have to anonymize your paper. I've never done a anonymized paper submission. This is the double-blind concept. You never, well, in almost all cases, you don't know who the reviewers are, but here the reviewers aren't supposed to know who the author is. And so I had to Google all that and figure out what the rules were and so forth, and I'm still not completely sure what the rules are, but this is what my affiliation now looks like in the paper that I submitted. And the conference, the official people in the conference said it was okay and it's off getting reviewed and so on and so forth. But during the review period, you have to be careful about social media. Like that. You're supposed to not try to drive it out there. So I'm not talking about what the title of the paper is or any of the guts of it and so forth. We'll probably talk about that next month, assuming the reviewing period will be done by then, which I think it will. So that's going out there. And again, like I said before, a lot of the stuff that came out of conversations that we have had, folks in the crew, in the Discord, questions in YouTube, all of that stuff has re-emerged in the discussion of the paper. And, I am biased. But yeah, we've got a movable, healable, growable, programmable, inheritable replicator. It's a little bit awesome. So we'll see. All right. So that's big science. And finally, Companionate Caring. This is my dad's book that was bringing out just because I wanted to get the words out there and also to help figure out how this whole self-publishing thing. The goal for this month was to get it into the stores. It is now in the stores. You can buy it at Amazon. You can buy it at Walmart. You can buy it at barnesandnoble.com. You can buy it at bookshop.org. And they even give a little bit of a discount. Most everybody is selling it for list price $24.99. It's expensive. It's a short book. It's not meant to be a number one bestseller. On the other hand, look at this. Look at this. We've sold 7 copies. Really doing numbers now. Thank you to everyone. And especially for the folks on the live stream, I so appreciate people who manage to, find the time to show up at the actual appointed hour. So I'm giving away 2 copies of Dad's book to the first 2 folks who say Companionate Caring okay in the YouTube live stream chat and somehow get me a physical mailing address associated with whatever their handle is sometime today. Okay, and that's just just a little bit. This is all me trying to pretend to be a marketing, instead of like whispering in a well, which is my preferred form of marketing. So hopefully a couple of folks who will be interested in taking a look at that will get it, and that'll be fun. And that's it. The goals for a month from now is clean living fish. I mean, what we saw was one big mess. I would also like to have a second species started. That might be too ambitious. Like I said, maybe the menagerie is going to be all fish. We'll see. Also, some first draft, some brainstorming about plans for the second half of 2023, because this is only taking us part way. And of course, more big fun. And that's it. Thanks so much for stopping in, whether in the live stream or coming back to look at it at any time. And I hope to see you next time. Okay, and that is it. I'm gonna blow my nose here. Okay, let's go over quick to the. All right, it looks like Quantumplation and Phoenix 1328 are the first 2 folks in. Sheldon Ackley was my dad. He died in 2008. He was a philosopher, and university administrator, and a huge ethical hard ass. So contemplation in Phoenix 13028. If you get me some kind of physical address that I can send it to, I will send those out. Thank you so much for playing in my great marketing giveaway. All right, so I am going to once again take a break here, get the cut down version rendering so that we can get the 15-minute version up as early on T2sday as we can. And then if anybody's still sticking around, I'd be happy to chat about that, anything afterwards. So hopefully that'll be quick. I'll restart the waiting room, and we'll go from there. So I'll be back in maybe 5 minutes. I don't know how long it takes. T2 demos. T2 demos. T2 demos. All right. It wasn't too long. I don't have a Patreon, but thanks for asking. You can become a Living Computation Foundation nerd if you're not already. If you can handle PayPal at livingcomputation.org. Uh, um, uh, but thanks for the support. Oh, hey, here's Dick. Uh, 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 um, and so yeah, so David, talk a little more about intercellular communication. Yeah. Uh, um, well, as always, and again, this is the bottom-up engineering approach. I am taking it one demo at a time and building what I need to make that demo work. And it's it's always a struggle because I'm a normal computer nerd, and so when I am faced with a problem, I never want to solve it if I can spend 10 times longer trying to come up with a general scheme that will solve all problems like it. But it's actually a usually a mistake for me to do that, and because my abstract computer science intentions are usually leading me wrong, and so I end up going back and well, wasting time doing this sort of thing before I figure out that just implement what you need, and do it as cleanly as you can, but clean it up the second time. Do it any way you can the first time. Get it to work somehow, and then see where you're at. So intercellular communication is exactly one of those kind of things. I imagined I was going to have a general packet mechanism that I could send things from one to another and have some kind of addressing scheme like, wormhole routing, send this to my northwest neighbor and then send it to his northwest neighbor and then send it to his southwest neighbor or whatever. Uh, um, but that is a tremendous amount of design that what should the packets look like, how big do they need to be, And, eventually I back off. And so my ideas of intercellular communication are, number one, what we just saw, which is cells being aware not just of the fact that there is something out in the world versus there isn't, but whether what is out in the world is another cell, and if so, about how big is it, and what is its relationship to me, all on a per side basis. And that in itself, just that much information. There's a cell that's size 3 at about this position on my northwest neighbor, is intercellular communication. It's stigmergic communication, and I'm taking advantage in the demos that we have so far. I'm taking advantage of the fact that the fins are supposed to be much smaller than the fish bod, to help distinguish between fins that between intercellular neighbors that we want to stay close to because we think they're fins versus things that we want to get away from because we think they're other fish or who knows what. Dynamic memory storage from the environment. Yeah, I mean, so that's what I've got. I mean, I get this? So yeah, so this is the demo that we actually saw at the beginning. It's still running, and if we let it go a little bit, it'll probably make the fans drive. I don't know if it's really possible to see this. Let's change the views here. All right. So can't really see him very much. Oh, and I can't see my hand against the thing, so we'd have to use so this blue thing right here, I think, is, yes, it's a fish bod probe. Oh, we can see him over here. You see these blue things moving around in the fin. Can we see that? And moving in and out. Unfortunately, I have this zoomed way in, so it's hard to see. So those blue things that are moving in and out from the center, which I think we can see now, those are carrying information from the edges to the controller in the center. And the controller is polling the edges, essentially, saying what is out there. And so, and we can see in this case, we've got a fin up here, which, there's all kinds of information going on, all kinds of detections going on. The Edge HG says, yes, there's something out there. It's size 2, and I'm at 1.1 or 2.0. So, in fact, actually, this is looking relatively good at the level of communication that this exists. So that would be an example of the, whoops. Let's go back here. That would be an example of the communication from the edge of the membrane to the inside content. At the moment, I expected to finish up this intercellular thing. I expected to have, let me go again, messages going deliberately through the membrane into a neighboring cell, or at least to the membrane of another cell. At the moment, I don't really have it. There's just one thing that, maybe you saw it. The fish can change direction. And it does that in part by deleting or attempting to delete the fins that it's got and spouting new fins in the direction which is supposed to be behind it now. And in order to do that, it actually sends a particle, it creates it near the root at the controller, which exfiltrates itself to an edge and then punches straight through, basically going ballistically a certain distance, like like a coronavirus opening up and chipping its way into a cell. And then it assumes it's inside the neighboring cell, and it starts to hill climb on the HC3 grid. And when it gets to the root, it kills the root. It deletes the cell. And that works kind of, but it's an incredibly powerful weapon. And there's stuff, it was going way too fast. That was quadratic time, the opening demo that we watched. If you look closely, there's times when one of a fish splits, and then the two of them are bouncing around, and they don't actually deploy their fins until they get a certain stage in their maturity. In particular, they have to copy all the code, which is originally in the center, off to the left-hand daughter. And it's after that code copy is complete that the fishbod controller is deployed and it starts to do fins and all of that. I didn't originally have it that way, but things were so crowded when all the code was right in the center that the probes that were trying to go out to the edges kept getting blocked and all kinds of problems. And I was trying to work around it, and I did make the probes be a little more stochastic so they actually have more navigation ability rather than just try to go straight. But still, everything was much easier once I finally said, wait, just wait until the code is out of the way and the center is nice and clear, and then we can have stuff go in and out and in and out and in and out. So that's intercellular communication. Eduardo Schnell, have you considered some kind of higher level language? Yeah, well, absolutely. Once again, step one is gain experience the hard way. Step one is, live rough, survive the first winter in the new world as a colony. And then step two is, start to build settlers, bring in better tooling and so on. And, I thought about some kind of organization chart mode where you could start thinking in terms of cells that have roles, like I am the upper fin, I am the lower fin, or I am the clockwise fin, I am the anti-clockwise fin, or I am the president, or I am the head of HR. Organizational chart, and thinking in those terms. We have roles that are filled by things out there, and we want to send messages based on roles. This is a message for HR, or this is a message for the clockwise fin, whatever it happens to be, and have some method of expressing that in some compact terms, which would then unfold into Ulam code and so forth. And I still want that. I really want that, but not ready to design it yet. Need to know how this kind of stuff is going to work, and then try to figure out higher level languages. And a little more casual down. Well, so I guess we did that. Contemplation, a little more casual down. I mean, we can go back and look at it again, and see. Oops. If I can figure out where I am here. There we go. So this thing is running. I'm surprised the fans aren't coming on. And this has been going for over a day, I think. And I keep wanting to kill it so that I can start another one, and then it keeps doing funny things. Like now we've got ending up with a single fin. As you can see, is quite a popular attraction. And I don't completely understand why that's happening. All of this only started working over the weekend, so as usual, I really don't know much of what's going on. But it was interesting enough that I put it on the grid like that, so it's out there doing whatever it's doing now. But some things that we can see. Look at this thing here. This fin here has pretty much lost contact. I think that's true. Well, it still thinks it has some inbound data. No, actually, that's outbound data. And so all of these blue things here are fishbod probes that have gotten completely out of whack. This has got fishbod probe cancer, this cell. And there's so many of them, it's blocking the way for all the other ones, so they're not managing to reach the edge that they're supposed to reach and come back, and therefore the controller, here's the fish fin, that's the controller for a fin, eventually times out and says, I haven't heard from, the southwest edge. So it tries to release another one, and this gets into fish bod probe runaway like that. So that's a typical example of one of the many problems that this code has. Now, here's another problem. I'm going to stop this. This little dot up here. That is one of those things that I was talking about. That's a fin kill atom that is meant to go from the fish bod controller out to the appropriate edge and then punch through into the fin, climb up, and do it. But it managed to get lost and missed the fin, and in its walking, it's trying to go one more step. So Walkie's Dest is trying to get to 16 minus 16 in this case because it's going northeast. And it can't get there because it ran into the edge of the universe. So, in fact, it's just bouncing around there like a complete idiot. And in the opening video, these unkillable zombie fin kills start to accumulate in various corners of the grid like this. So when set the goal for next month of clean living fish, that would be an example of this is not clean living at the moment. And there's many other problems. But again, see, there they are. Look at that. We have a whole little colony of fin kills there that are all bopping around, wishing that they could go one more step so that they would then move into and I believe if they had actually managed to get to 1616, they would have, and so they would have thought they were inside the cell and they would start to hill climb. They actually would clean up themselves once they look around and say, wait a minute, I'm not inside a cell at all. Something must have gone wrong. But during the ballistic walkies phase, they don't do that, and clearly they should. So that's another step in the sad little and these things are just going crazy. They're bouncing off each other and so forth. So that is the current state of the fins. Let me go back and see what's happening in the. Wow, look at all this stuff. Thanks so much, folks, for coming and talking about stuff. I really appreciate this. Cool to see how this interacts with some of the older demos. Yeah, right. Could maybe think about it. The city demo, probably not, because that is written in whoops. Am I? How am I supposed to do that? I don't really understand how I'm supposed to do that. That's written in C++, and I think that code has officially rotted. Here come our fans. But some of the other demos, it's possible. And in fact, I mean, there's a bunch of stuff here. Oops. Here. Why is that? That's weird. Feel like I've gotten we should be able to click it. There we go. There's a bunch of stuff. There's a ton of elements in here that I don't actually use anymore. But they don't actually do anything all that exciting. But maybe. I mean, certainly, well, put it this way. We could put in Dragon Res. I've done some experiments with that. And it's bad for the cells. They put up a fight. I'll throw in some drag just to be, whoops. Because they can heal quite a bit. I mean, so for example, if we go in with the eraser, and we chop off a tip of one of these cells, it actually heals up pretty well. It heals up pretty fast. But going dreg is much nastier than that. Just pulling out individual things when it might be in the middle of a move, and I feel pretty good about the HC3 movement code at this point. It still can deadlock. It only has so much redundancy, and it has to make heuristic guesses if it's in inconsistent situations. As long as everybody obeys the rules, and nothing gets unexpectedly killed, then it's pretty robust. But we're talking here about erasing stuff. Let's chop off a bit again and see if it can recover from a bigger chunk. All right. Whoops. Well, this one's done. I killed this one. That's too bad. How about this one up here? If we just slice off the top, see how well that does. It tries to regrow quite quickly, and it's showing damage. All these red here is the dew line, the warning system that signals from the edges of the cells into the center is signaling damage. But it's regrowing, and the membranes are reforming, and the M sensors and the intercellular goo is coming back, and there that red guy at the end there is an M tip. It's a special atom whose only purpose is to be at the corner of a diamond. And I've had a lot of trouble with the M tip in the last month. That if it ends up getting in the wrong place, that turned out to be one of the main unexpected for me reasons why the fins kept falling off. Because it would get an M tip in the wrong place, and that would end up sending warnings, just because of the way it all worked out, sending warnings up to the root saying, watch out, we have a problem in the north and west direction, or whatever it happened to be. So the fin no longer was willing to head in the direction that it needed to head to, because it thought there was an obstacle there, but the obstacle was in fact only a misplaced M tip that took forever before it finally erased itself and the thing healed up. And it would erase itself eventually, and it would self-stabilize in the long run, but it was a really long run, and the fin was like halfway across the grid before it necessarily up. So one of the things I actually did this month was re-implement the M-tip stabilization logic, so that it dies quicker when things don't look right. Which actually does have consequences, because even when, as we just saw here, for example, if I erase a bunch of like that, okay, so I erased all the membranes from the side. Now it may well, we'll see what happens. There it is. So the M-tip erased itself because it counts on seeing sensors in two neighboring directions. It wants to see, in this case, it wants to see northwest sensors and northeast sensors. And if it doesn't see both, it gets antsy. And now it gets antsy quite quickly. And before, it used to be stable longer, but that led to problems. So now it erases itself quicker, and then has to regrow. So that's that. Oh, man. Sinus is terrible. All right. Oh, wow, the X-ray tool. Okay, all right. Yeah, I called it the X-ray tool. So you're really gonna push me, huh? All right. Let's let's try to blast in the with the X-ray tool. Of course, there isn't that much left here at the moment. Well, there's a bunch. Yeah, there's a bunch of stuff. Oh, and as long as I'm talking about this stuff, and we're having such a nice little chat here, I did something that made me happier. My single biggest fun of this last month, as far as the T2 tile project is I reorganized the tools up here. Unfortunately, I can't zoom in the toolbox. But there are 5 tools that I use all the time: the pencil, the eraser, the spark tool, the magic wand that delivers events to things specifically so I can see what happens if this guy gets an event right now, the atom view tool, and the tile select tool, which is what turns on the ability to run time forwards and backwards in a tile to see what happened in the past. I redid the MFMS code so that they tools are now all to the left. So 1 means pencil, 2 means erase, 3 means spark, 4 means atom view, and 5 means tile select. So they're all on my left hand. And furthermore, the run button, which was for space, but on my Kinesis keyboard, space is on the right hand. So now there's an alias. Tab works as an alias for run. So now I can do all the things that I need to do with my left hand. Why didn't I do that 5 years ago? It's so much better. But that means, for example, that the X-ray tool, which is over here, is now way over on 6 or 7 or something like that, which is not convenient to my left hand, but who cares? Because there it is. All right, so here's the X-ray tool. Why don't we X-ray one of these fins, for example? All right, so I just gave it one little blast, and that was the end of the story for that guy. And if we do a little blast, see, is that even staying in? Yeah, it is. I gotta blow my nose again. It's looking like maybe it healed up there. Let's try a blast over on this one. Bam, 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 bam. Still seems okay. All right, that's a pretty big hit. Uh, um, so far, the main thing that there's reason for hope here is that the grid is not in the middle of moving. It is not in the process of trying to shift. And that's the single biggest thing that tends to mess things up in these kind of situations. I think, in fact, the reason it's not moving is because oh, I'm so happy I can just do it. Uh, the fishbod controller is in state. Whoops. Please stop for a minute. The fishbod controller is in state 4, which is split. It's actually trying. So when the fishbod controller decides it's time to go ahead and replicate, essentially what it does is it just gives up control to free will. It just goes back to the root and says, okay, I have no more advice for you. So the root does what it used to do, which is try to avoid everything except for empty space, and goo, and grow until it reaches full size and then split and so forth. So it's in the middle of that. So I'm not exactly sure why it isn't moving, or maybe it will. I don't know. But I'm willing. Oh yeah, it did move. So here's the root now. I super do wish MFMS could learn how to track, when you put the atom view panel on a particular atom and all of a sudden the atom moves out from underneath it, you'd have some kind of little automatic tracking button where if you turn on the automatic tracking and the type of what's under the thing changes, it would search the von Neumann neighborhood or the Moore neighborhood, whatever it is. And if it found one of the same type that it used to be tracking, it would automatically switch to it. Something like that would help a ton. Ooh, ooh, ooh. It's growing. Yeah, that might be. Is that enough to reproduce? Yeah, that's max hops 18. So we should be able to watch this thing. There it goes. Uh, uh, it's miracle of birth. Oh, and of course, when you're doing splitting, it's also, birth, death, yin yang, like that. And whoops, my keyboard is messed up now. I don't really understand what's going on there. I get the super key stuck down, and now everything is super this and super that. All right. Well, this is super fun. Folks, thanks so much for hanging around and playing along. We'll see. I really don't know. The von Neumann neighborhood is north, south, east, west. And the Moore neighborhood is that plus northeast, northwest, southeast, southwest. So the von Neumann neighborhood is 4 states or 5, including the center. The Moore neighborhood is 7 or 8, or is 8 or 9, including the center. Since we have such a big event window, we can reach out at a Manhattan distance of 4 in one go. The von Neumann neighborhood constraints that lots of cellular automata have, we don't have. We have more complex architectural issues underneath because of the big event window, but then we have corresponding easier programming issues in a lot of ways because of the big event window. But there's a lot of things like the HC3 grid, the diamond grids, that when they move, they only move north, south, east, or west 1 square. And a lot of things are like that because they want to be able to make predictions about what they're going to see, the range of possible things that they will see if everything is going all right. And if you have it so that it can jump all over the place, then you have less ability to have confidence in what's going on. Whereas if you're here and you go 1 step east, you should still be able to see almost everything that you could see from when you were 1 step west. And as a result, there's lots of atoms like the HC3 grid that if we had an atom viewer that would only check north, south, east, west when it loses track of some particular atom, it would have a really good chance of finding the atom, finding the right one, and picking it back up again, like that. But the von Neumann neighborhood and the Moore neighborhood are the 2 biggest, most popular ones that are used in traditional classical deterministic cellular automata. So like the Conway's Game of Life uses the Moore neighborhood, for example. And all right. Well, folks, we're almost to the top of the hour, and we actually were kind of like yakking the whole time. That's pretty good. Contemplation. I will think about what elements it might be possible to toss in. I certainly have had demos with swap lines. Where swap lines were still in things, and you could do a fair bit with it. It would be interesting to see if or how badly, put it that way, an HC3 grid would get messed up if you passed a swap line over it. Because part of the successful swap line stuff deals with it's cooperative. The swap lines were mostly in the SPOTS paper, which was like 3 years ago, and they had a stage priority. So yeah, P in SPOT stood for priority. And so there was a scheme that when you looked in your neighborhood, if you saw anything of higher priority, then you just went to sleep. And that was what allowed the swap line to succeed, is because it was higher priority. So it could do all of its business and move all the way through, and everything underneath it just, was narcoleptic. And when they woke up, everything looked exactly the same as it did when they fell asleep, except now they were 1 square moved over. But they missed it entirely because of the priority scheme. There's no priority scheme here. So as the swap line is trying to go through and it's moving HC3 atoms, there's every possibility that the HC3 atom is going to see, it's going to wake up, it's going to have an event in the middle of that inconsistent state, and it's going to decide to heal up, and it's going to be bad. That would be the prediction there. Anyway. Okay, so our lucky winners, send me an email or a DM in the Discord or whatever it is. Get me a physical address, a name and an address for you, so I'll send out your prizes. And everybody, thanks so much for hanging around. And hope to see as many folks as possible in a month. All right, I'm gonna call the stream now, I guess. I think, in fact, the rendering may in fact be done. I'm not sure. The rendering may in fact be done. So okay, that's it. I'll put a little text message first. Oh, I can't type. My keyboard is messed up, so I can't type. All I can do is click. Can I select a thank you and paste it in there? Okay. There's my message. Okay, folks. Hope to see you next time. That's it.